Okay, for question number 31, part A, it's given that a card from a well-shuffled deck of 52 playing cards is lost. And from the remaining cards of the pack, a card is drawn at random and is found to be a king. So we have to find now the card is drawn, so we have to find the probability of the lost card being a king. So if a card is drawn, if the card is lost, it can be a king or cannot be a king. So these will be our two primary events. So I'm going to specify these two as E1 and E2, so that E1 be event of losing a king card. Now, if we have to lose a king card, it has to be drawn from the king cards, and we have total of 4 king cards out of 52, which gives us the probability as 1 as 13. 1 by 13. Now E2 be even of not losing a king card. So the probability of not losing a king card, it has to be from the non-king cards, and the total non-king cards are 48 out of 52, which gives us this is uh, with 4 we can so this is 12 and this is 13, so this is 12 by 13. Now we have to draw a king card, so we have to draw now a card, and let's say that A be the event of drawing a king from the remaining cards. So the card is lost, and now we have to draw a card, and let's say A be the event of drawing a king card from the remaining cards. So A be event of drawing a king card from the remaining 50 remaining 51 cards. So when the card is lost, it could be a king or it cannot be a king. So this is the probability of losing a king card from the 4 king cards. This is the probability of not losing a king card, and A be the event of drawing a king from the remaining 51 cards. Now let's find out the probability of getting a king card when a king card is lost. Now, when the king card is lost, so what is the probability of getting a king card? So when the king card is lost, that is, we have lost 1 card, so the remaining are 51, and we have to get the king. So if the king card is lost, remaining king cards are 3, so out of 3 we can get the king. So now let's find out the probability of getting a king card when king card is not lost. But a card is lost, so the remaining cards are 51. Now we have to get a king, but it's uh, but the card lost is not a king card. So we have total of 4 king cards, so we 4 out of 51. Okay. Now what is asked in the question is that we have to find the probability of the lost card being a king. So that means that the lost card is king, and now we have to get a king when the lost card is king. So we have already got the king, and it has to be from the among the we have to find the probability when the lost card is king. We have already got the king, so this is what we have to find. That is probability of getting a king card when the lost card is a king. Okay. So using the Bayes theorem, so this is the probability of by E1 into probability of E1. Sorry, this is probability of E1 using the Bayes theorem. And once again, we have total of 2 events. So this is probability of A by E1 into probability of E1 plus probability of A by E2 into probability of E2. Let's put in the respective values. So probability of A by even is 1 by 13 into 5 by 51, sorry, 3 by 51. So this is 3 by 51 divided by 1 upon 13 in 3 by 51 plus probability of A by A2. A2 is 12 by 13 into 4 by 51. Okay. Now 13 into 51 is, so 13 into 51 is equal to 663. So this is 663 upon 3, and this is once again 3 upon 663 plus 12 into 4 is 48 upon 663. Okay, so now this is equal to 3 upon 663 divided by, now here the LCM is 663. So this is 3 plus 48. We can strike the same denominator. So this is 3 upon 3 plus 48 is 51. And this is 3 upon 51, which will finally give the answer as this is 7. So the required probability is 1 by 17. So 1 by 17 is the probability of the lost card being a king